In this video, we're going to talk about calculating pH from the hydronium ion concentration. So pH is the logarithm of the hydronium ion concentration multiplied by -1. The alternate to that is the hydronium concentration is equal to 10 to the negative pH. So the power 10 to the power of the negative pH. For pure water, pH is negative log of 1 times 10 to the negative 7th. The hydronium ion concentration and the hydroxide ion concentration are equal for pure water because the pH is 7, and the concentration of both of those is 1 times 10 to the negative 7th, so that's where we get that number. And the negative log of 1 times 10 to the negative 7th is 7.0. So that shows you how you get the pH from the concentration of the hydronium ion. So as the pH decreases, so the pH decreases as the hydronium ions increase and the hydroxide ions decrease. The pH scale is logarithmic, and 1 pH unit represents a 10-fold change in ion concentrations. So a solution with pH of 2 is 10 times more acidic than a solution with a pH of 3, and 100 times more acidic than a solution of pH equals 4. All living organisms, including ourselves, are sensitive to pH. If the pH of a lake changes by even 1 pH unit, most fish eggs will not hatch, and many adult fish will die. If the pH of our blood rises or falls by more than 1/10 of a pH unit, it's a medical emergency. Injuries such as gunshot wounds to the stomach are often fatal because of the damage caused by the low pH of the gastric juices that spill into the abdominal cavity. So to practice, we're going to determine the pH of solutions and with a hydronium ion concentration of 1 times 10 to the negative 9th. And then we're going to determine the hydronium ion concentration from the pH. So pause the video, work out the problems, and when you're done, we'll come back and we'll check your answer. So for the first one, we're going to write out our KW equation. Our KW is the concentration of the hydronium ions times the concentration of hydroxide ion equals KW, which is 1 times 10 to the negative 14th. So we know that the hydronium ion concentration is 1 times 10 to the negative 9th. So 1 times 10 to the negative 9th. Oops, sorry. It's getting ahead of myself. We don't need that part. We just need to find out the pH using our equation. So pH is equal to negative log of the hydronium concentration. So pH is equal to the negative log of 1 times 10 to the negative 9th, and this is equal to 9.0. So the pH of this solution is 9. What is the hydronium ion concentration? So to find the hydronium ion concentration, it is 10 to the power of the negative pH. So this is 10 to the negative 2 power, which is 1 times 10 to the minus 2 molar. One thing I forgot to add on this top one, it says, is the solution acidic, basic, or neutral? We have a pH of 9. pH of 9 is greater than 7. If something is greater than 7, that means it is basic. Equal to 7 is neutral, less than 7 is acidic, greater than 7 is basic. So what is the pH of a solution with a hydroxide ion concentration of 1 times 10 to the negative 9th? So this is when we use our KW equation. So we have KW is equal to the hydronium ion concentration times the hydroxide concentration, which is 1 times 10 to the negative 14th. We want to find the hydronium concentration, so we can use our negative log equation, and we're given 1 times 10 to the negative 9th. We're going to divide both sides by 1 times 10 to the negative 9th. And this gives our concentration of hydronium ions is 1 times 10 to the negative fifth. To find pH, we use our equation negative log of the concentration of hydronium ions. So pH is the negative log 1 times 10 to the negative fifth, which is equal to 5.0. Then the equation that asks, is this solution acidic, basic, or neutral? The pH is less than 7, so 5 is less than 7. So this is an acidic solution. So in summary, the equation to determine pH is negative log of the concentration of the hydronium ion. As hydronium ion concentration increases and the hydroxide ion concentration decreases, pH decreases. The pH scale is logarithmic,